Welcome to day 30 of Math 111. In this lesson, we're going to be looking at rational numbers and some of the properties. The properties that we will be seeing today are properties that we've seen with other sets of numbers. The purpose of the lesson today is to demonstrate that these properties do apply to the rational numbers. We're going to begin with the definition of an additive inverse. If R is a rational number represented by the fraction a over b, its negative or additive inverse is the rational number represented by the fraction negative a over b. The idea of an additive inverse is not new to us. We encountered that with the integers. When additive inverses are added together, the sum is 0. The same is true with rational numbers. We can see the example at the bottom of the screen. When you add a over b and its opposite, then the sum is 0. This concept is used in algebra frequently. Here are some properties of addition of rational numbers. These properties are things that we have seen before and have discussed in relation to integers. I'm not going to read these to you. I want to remind you what the function is for these properties in the rational numbers. Just as we've seen before, closure means that when two numbers are operated on, then the result is back in the same set. The commutative property has to do with the order of the operation, in this case, addition. The associative property has to do with the way the terms are grouped. So you'll notice that your rational numbers are grouped differently on each side of the equal sign. Just as with the integer, 0 is the additive identity. And as we saw on the previous screen, we do have additive inverses. All of these properties are very important. You should become very familiar with them and be able to use the right terminology. Just as with the integers, subtraction is equivalent to the addition of the negative. So you'll see in the theorem here that it's demonstrated that when two fractions are subtracted, it is equivalent to adding the opposite. This notion is also very important. On this screen, we have the properties of multiplication of rational numbers. We have encountered these before. We have here a closure property for multiplication, just as we did in the integers. When two rational numbers are multiplied, the product is also a rational number. The commutative property has to do with the order of multiplication. And the associative property of multiplication has to do with the way the factors are grouped. We have a distributive property of multiplication. You can see the demonstration here with the rational numbers. We had a distributive property that we looked at with the integers as well. We have the multiplication by 0 property. This says that when 0 is a factor, then the product is 0. 1 is the multiplicative identity, just as with the integers. And we have multiplicative inverses. We will look at multiplicative inverse in more detail. In the integers, we do not have multiplicative inverses. In the rational numbers, we do. The multiplicative inverse of a rational number is the reciprocal of that rational number. You'll notice that you've got a fraction r defined to be a over b. The inverse, represented by r to the negative 1 power, is equal to b over a. When we multiply a rational number and its inverse, we get 1. We have some examples here. I'm sure you know what reciprocals are, but just to remind you, if we consider the fraction 3/4, the multiplicative inverse is 4/3. Remember, to form the reciprocal, you invert the fraction. I put the next example in here because some students have trouble working with mixed numbers. The multiplicative inverse of a mixed number is found by first converting the mixed number into an improper fraction and then inverting. So we see that we have the mixed number 2 1/3 as an improper fraction. This is 7/3. And so the reciprocal is 3/7. Make sure you understand this and can do this. With the rational numbers, we have the idea of being able to order the numbers just as we do with the integers. This means that we can use expressions like less than or greater than when comparing a pair of rational numbers. We have the transitive property. This property relates three rational numbers. So if R, S, and T are rational numbers, and if R is less than S, and S is less than T, then R is less than T. So we can make this ordering. We have an addition property related to the ordering of the rational numbers. So if R is less than S, and we add the same quantity to both sides, then that order is preserved. So here we're adding T to both sides. R plus T is then less than S plus T. The same thing is true with multiplication. If we are multiplying both sides of an inequality by a positive rational number, then the relation stays the same. So we have rational numbers R and S, and R is less than S. If we multiply both sides of that inequality by a positive rational number T, then R times T is less than S times T. And you can see what the expressions look like when you actually use fraction notation. If T, the multiplier, is less than 0, then it changes the ordering of the product. If a rational number R is less than another rational number S, and T is less than 0, and we multiply both sides of that inequality by T, then we have the result that R times T is now greater than S times T. You might want to try this with some examples and see that it really does work. The last property that we have here is the trichotomy property. Tri means 3, and what this says is that there are only 3 possible cases when comparing a pair of rational numbers. If we have R and S as our rational numbers, then either R is less than S, or R is equal to S, or R is greater than S. It must be that one of these 3 is true. We have here the density property of rational numbers. This concept is very interesting, and it is used in higher mathematics. The density property tells us that between any 2 rational numbers, there's another rational number. It doesn't matter how close your rational numbers are on the number line, we can always find another one that's in between. This result is not trivial. We have gone through the properties associated with rational numbers very quickly. As you noticed, most of these properties are properties that we have seen in relation to the integers. Make sure that you know and understand these properties that we've talked about in the lesson today. Make sure you know the names, and make sure you understand how these are used.